everyone, welcome to another video. Let's find the values of x for which the logarithmic equation on the board is equals to 1. Now, to solve this question, I'm going to make use of one of the properties of logarithms known as change of base property. So using the logarithmic property, so we have log to base a of b, this will be equals to 1 over log to base b of a. So which means if we have log to base x of 3, this will be equals to 1 over log to base 3 of x. So now the equation we are given is log to base 3 of x minus 2 log to base x of 3 equals to 1. So which means now that we have log to base x of 3 to be equals to 1 over log to base 3 of x. So then this equation will now be log to base 3 of x minus 2 multiplied by 1 over log to base 3 of x equals to 1. Now let's do some substitution in this case. Now let's make log to base 3 of x equals k. So let k equals to log to base 3 of x. So which means this equation will now be k minus 2 multiplied by 1 over k equals to 1. So in this case, this will be k minus 2 over k equals to 1. So now I'm going to multiply through this equation by k because that is because we need to get rid of this k. All right, so now we have k minus 2 over k, equals to 1. So I'm going to multiply through the equation by k. All right, so k multiplied by k, this will be k squared. Then k multiplied by minus 2 over k, this will be minus 2. And that will be equals to 1 multiplied by k, that will be k. Then this equation in standard form will be k squared minus k minus 2 equals to 0. All right, now we have a quadratic equation in letter k. But what we want to do is to find the values of x. So we need to first find the values of k after we let log to base 3 of x to be equals to k. All right, so in this case, to factorize this, of course, this will be k squared minus 2k plus k minus 2 equals to 0. That is the two numbers that multiply towards minus 2 and add to -1, that is minus 1. All right, so in this case, this will be k squared divided by k. This will be k minus 2, then plus 1 into k minus 2 equals to 0. So here we have k plus 1 multiplied by k minus 2 equals to 0. So that means k plus 1 will be equals to 0, then k minus 2 will be equals to 0. Now the first value of k is minus 1, Then the second value of k is 2. So we have k equals to minus 1 and then k equals to 2. All right, now let's recall. Now we recall that log to base 3, log to base 3 of x is equals to k. So when the value of k, when k is equals to minus 1, so we're going to have log to base 3 of x equals to minus 1. Now in this case, this will be equals to x equals to 3. This will be x equals to 3 raised to the power of -1, so that x will be equals to 1 over 3. This is the first value of x. So this is the value of x when the value of k is equals to minus 1. Okay, so now, and let's not forget that 3 raised to the power of minus 1, that is when we have negative index, okay, negative power. Okay, that is what we have here to be 1 over 3. Also, when k is equals to 2, okay, and we know that log₂ base 3 of x is equals to 2. So in this case, we're going to have x to be equals to 3 raised to the power of 2, which implies that the value of x will be what? 9, because 3 raised to the power of 2 is 3 times 3, which is what? 9. So therefore, the two values of x, we have the first value to be 1 over 3, okay? Then the second value is what? 9. So this is our solution. Now, let's verify our solution. Okay, let's verify our solution. Now, we have the equation to be log₂ base 3 of x minus 2 log₂ base x of 3 equals to 1. So now, when the value of x is 1 over 3, okay, then we're going to have log₂ base 3 of 1 over 3, okay, log₂ base 3 of 1 over 3 minus 2 log₂ base 1 over 3 of 3. Okay, now we want to know if this is going to be equals to 1. Okay, now we know that this is same as log₂ base 3 of 3 raised to the power of minus 1, then negative. Now in this case, this will be 2 log₂ base 3 raised to the power of minus 1 of 3. Now, will this be equals to 1? Okay. Now, we're going to what? Bring this, multiply this power to the what? We're going to apply what we call the power rule of logarithms in this case. And this will be negative 1 log₂ base 3 of 3 minus, now in this case, this will be plus 2 log₂ base 3 of 3. That is, if we use the property log₂ base a to the power of x of b, this will be equals to 1 over x log₂ base a of b. So this is one of the properties of logarithms, okay? One of the properties of logarithms. And we know that log₂ base 3 of 3 is 1. Okay, so in this case, this will be minus 1 plus 2. And that's what? 1. So which means the value of x, which is equals to 1 over 3, okay, is one of the solutions to this equation. All right. Now, also, so let's continue from here. Now, when the value of x, the second value of x, when x is equals to 9, okay, we want to verify, okay, so we have the original equation to be log₂ base 3 of x minus 2 log₂ base x of 3 equals to 1. So when the value of x is 9, so we have this to be log₂ base 3 of 9 minus 2 log₂ base 9 of 3. Now, will this be equals to 1? Okay, now I'm going to use this property in this case. I'm going to use the same, this property. I'm going to use it in this case. So this will be, of course, we know that this is same as log₂ base 3 of 3 raised to the power of 2, because 3 exponent 2 is 3 times 3, and that will be equals to 9, minus 2 log₂ base 3 exponent 2 of 3, okay? Will this be equals to the right hand side, which is what? 1. So applying the power rule of logarithms in this case, so this 2 becomes the multiplier. So we have log₂ base 3 of 3 minus 2 multiplied by 1/2 of log₂ base 3 of 3. Using this property, log₂ base x a raised to the power of x of b, that will be equals to reciprocal of x multiplied by log₂ base a of b. So in this case, this will be 2, because log₂ base 3 of 3 is 1. Then minus 2 divided by 2 is 1. So we have 1, because log₂ base 3 of 3 is 1. So that 2 minus 1 will be equals to 1. So which means that the two values of x, as in which is our solution, that is x equals to 1/3 and x equals to 9, okay, satisfies this equation. With that, we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.